we have learned what is a indefinite integral and what is a definite integral, and how that is related to finding area of a specific region. Let's now look at another type of application, which is coming from physics. So if we're given an acceleration function and the initial velocity, we can use that information to find the velocity function. And with that velocity function plus an initial position, we will be able to find the original position function. All right, so what does that mean? Let's look at an example. I have a moving particle that moves along the x-axis with an acceleration given by this function ft. Okay, and you know that t is measured in seconds, and the s, the position function, is measured in meters. If the initial position is given by s of 0 equal to 3, and the initial velocity is given by v of 0 equal to 4, then we want to find the position function at t seconds. Okay, so notice that we're given this information, the acceleration function, and we're given a initial velocity as well as the initial position function. So how do we use this to find the position function? So we're looking for position function s of t. All right, okay, so we know that a of t is obtained by differentiating the velocity. Hence, to get v of t, what we need to do is to integrate f t. Okay, and f t is given, which is 6t plus 2. So we find its antiderivative. Okay, so this is a generic one. All right, so now if we use the information, v of 0 is equal to 4, and if we use what we just found, okay, here v of 0 is equal to, let me move it down to this line. V of 0 is equal to 3 times 0 squared plus 2 times 0 plus c, which by straightforward computation is equal to c, so they're supposed to be the same, right? So we know that c is equal to 4. Hence, now you have the velocity function being 3t squared plus 2t plus 4, right? So we're gonna do this trick again. Use the velocity function here as well as the initial position to find the position function. Okay, so note that s of t, v of t is derivative of position, right? Okay, where s of t is the position function. Alright, so then we have an s of t being an antiderivative of the velocity. Alright, we just found the velocity, so just plug that in, 3t squared plus 2t plus 4 dt. This gives you t cubed plus t squared plus 4t plus another constant. We've used the c, so let me use k here. Alright. So now s of 0 is equal to 3. So I use that information. I know s of 0 is equal to 3. This is a given, right? And I use the function that I just found. So s of 0 is 0 cubed plus 0 squared plus 4 times 0 plus k. And then straightforward computation, this is equal to k. So these two numbers are supposed to equal. So therefore, we know k is equal to 3. Hence, the position function is equal to t cubed plus t squared plus 4t plus 3. All right.